So good afternoon, everyone. So now we are going to discuss some problems on experimental proof of DNA replication, semi-conservative DNA replication process. So now the first problem, in E. coli, when N14 labeled DNA molecules are, so now down, in E. coli, in Escherichia coli, when N14 when N14 labeled DNA molecules are labeled DNA molecules. So N14 labeled DNA molecules are transferred into NH4Cl containing medium. Transferred into NH4Cl medium. N15 means heavy isotope containing medium. NH4Cl medium. Right. So this is a statement. And allowed to replicate for 3 generations. And allowed to replicate for 3 generations. 3 generations. And now question is, find the ratio of N14 to N15 strands. So find the ratio. Find the ratio of N14 to N14. This is N14. N14 to N15 strands. N15 strands. So this is the actual question, right? Then better to take options. First option 1:8. First option 1:8. Second option 1:7. Third option 2:7. 2:7. Then fourth option 2:3. So these are the options. Question here is, in E. coli, when N14 labeled DNA molecules, it means light DNA molecules containing bacterial cells transferred into heavy isotope containing medium and allowed to replicate for 3 generations, but find out the ratio of N14 to N15 strands. So what is the ratio of N14 and N15 strands? So they are asking strands information or DNA molecule information, right? So better to take DNA molecules first. Okay, imagine it is one DNA molecule. So in this DNA molecule, this strand is N14. So this strand information also N14. Why? Because light DNA containing bacterial cells transferred to heavy DNA containing medium. Right. Then, so this DNA molecule transferred to NH4Cl medium. NH4Cl, heavy isotope containing NH4Cl medium. So medium is NH4Cl. Okay, during replication process, these 2 strands separated from each other. So act as parental strands. Okay, this is parental strand and it is another parental strand, N14 and 14. Both of them separated from each other and act as parental strand during replication. Okay, what about newly synthesized strands? So that newly synthesized daughter strands are N15. Why? Because when we transfer that N14 DNA molecules into the N15 medium, so that N15 heavy isotope incorporated into the newly synthesized daughter DNA. Right, in this way, first replication completed. So first generation DNA molecules, these are first generation DNA molecules. Then you can take second generation again. See, in second generation, these two DNA molecules gradually duplicated into 4 DNA molecules. But how so? So during replication, that strands separated from each other. So this is N14 strand. Then this is N15 strand, parental strand only. Then this N14 parental strand. Then N15 strand. And what about newly synthesized DNA molecules? N15 only. Why? Because medium has heavy DNA, heavy isotopes. N15, N15, here it is N15, then N15. So totally hybrid DNA molecules, two hybrid DNA molecules, two heavy DNA molecules formed in second generation. In second generation, these are heavy DNA, N15, N15, heavy DNA, N15, N15, heavy DNA molecule. And these two are heavy DNA, these two are hybrid DNA. So what is the ratio of hybrid DNA and heavy DNA here? 1:1. Not light, heavy. Then next, in third generation. What about third generation? So in third generation again, they act as parental strands as well. N14 strand, N15 strand. N14 strand, N15 strand. Then here N15, N15. Here N14, N15. These are parental strands only. Here N15, then N15. Totally, the strands separated from each other during replication process. But newly synthesized DNA strands are completely N15 strands. See here, N15. Newly synthesized DNA strands of N15. So totally, here also N15. So this is N15. So here also N15. So here also N15. Okay, right? So this is third generation. So in third generation, totally DNA molecules are 8. So in fourth generation, DNA molecules 2. In second generation, 4. In third generation, 8. In that 8 DNA molecules, hybrid DNA molecules are 2 only. 2. So identify that hybrid DNA molecule here, N14 and N15 strand. And one more. So here it is N14 and N15 strand. So totally DNA molecules number 8. 8 DNA molecules. Strands, DNA strands of 16. So DNA molecule number 8. 1, 2, 3, 4, 5, 6, 7, 8. So strands again, 8 to the 16 strands. So in that 16 strands, only 2 strands are N14. In that 16 strands, total number of strands 16. So in that 16 strands, only 2 strands are light N14. So N14 strands of 2 is to N15 strands. What about N15 strands? 14. 2 is to 14 is equal to 2 to the 1, 2 sevens are 14. So 1 is to 7. So what is the ratio of N14 and N15 strands here? 1 is to 7. So which option is correct? So second option is correct. So the ratio of N14 and N15 strands. First, you have to identify that question is either strands or molecules. So which type of question they are asking, you have to identify it earlier, right? Either they are asking DNA molecules, number of DNA molecules or number of DNA strands. You have to check once. Here they are asking strands information. Okay, strands. So here 16 strands. In that N14 strands of 2. N15 stands on 14. It means what is the ratio? 1 is to 7. Hey, they're asking strands, not DNA molecules. Note it down. Answer is 1:7. Next, so one more problem on semi-conservative DNA replication process. Note down one more problem. So one strand of a DNA has labeled thymidine. One strand of DNA. One strand of DNA has labeled thymidine. So labeled thymidine means radioactive thymidine. So in double stranded DNA molecule, one strand of DNA has radioactive thymidine. Labeled thymidine means radioactive thymidine. So it is allowed to replicate in a radioactive medium. It is allowed to replicate. It is allowed to replicate. Allowed to replicate in radioactive medium. In radioactive medium. Radioactive medium means radioactive thymidine medium. After 3 divisions, how many strands of DNA will have labeled thymidine? After 3 divisions, after 3 divisions, how many strands of DNA will have labeled thymidine? How many strands, it means DNA strands, will have radioactive thymidine? Radioactive thymidine. Radioactive thymidine. This is the question, right? So read that question carefully. One strand of DNA has labeled thymidine. It means it is a double-stranded DNA molecule. In that double-stranded DNA molecule, only one strand has radioactive thymidine. Only one strand labeled with thymidine. Then it is allowed to replicate in radioactive medium. After 3 divisions, so how many strands will have radioactive thymidine? This is the actual question. So note down options. First option 16. Second option 15. Third option 2. Fourth option 3. These are the options. First option 16. Second option 15. Third option 2. Fourth option 3. So you can take a DNA molecule. Okay, this is DNA molecule. In this DNA molecule, only one strand labeled with thymidine, radioactive thymidine, but other strand is normal. Other strand is normal strand. Okay, right? Allowed to replicate in radioactive medium. After 3 divisions means 3 generations. No? 3 generations. Okay, it is radioactive medium. R medium means radioactive medium. Imagine. Okay, they are allowed to replicate in radioactive medium. Okay, these two strands separated from each other and act as parental strands. So one strand is already radioactive thymidine, other strand is normal. They act as parental strands. So newly synthesized strands of thymidine strands. Thymidine strands labeled DNA in first generation. Okay, you can take second generation again. So in second generation also the strands separated with each other and act as parental strands. Here T, 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 except this strand. One strand is normal. Better to take one strand is normal. So remaining strands are thymidine strands. And newly synthesized strand also labeled strand only. But what about one strand here? One strand is normal strand. Then this is second generation. You can take third generation again. In third generation, 4 DNA molecules turns into 8 DNA molecules. See, 1, 2, 3, 4, 5, 6, 7, 8 DNA molecules. Am I right? So in these 8 DNA molecules, all DNA strands labeled with thymidine except one strand. Except one strand, right? Except the last strand, remaining strands are radioactive thymidine. So now which option is correct now? So how many strands will have radioactive thymidine? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Except one strand. So answer is second one. Second option is correct. 15 strands are radioactive thymidine strands. Note it down. Note down, no? The problem. And one more problem. So you can take another model, other problem. E. coli was allowed to grow in a medium containing N15. E. coli was allowed to grow. E. coli was allowed to grow. Allowed to grow. Allowed to grow in medium containing N15. In medium containing N15. Medium containing N15. Heavy acido. So then it was allowed to grow in N14 medium. And it was allowed to grow in N14 medium. N14. So N14 medium. So N14 medium. For 3 generations. For 3 generations. 3 generations. So how many number of DNA molecules will be with N15? How many number of DNA molecules will be number of DNA molecules with how many number of DNA molecules will be with N15? Will be with N15. How many DNA molecules will be with N15? N15. Right? So first option 2, second option 8, second option 8, third option 4, fourth option 0. So which option is correct here? Read the question carefully. That E. coli, Escherichia coli bacteria was allowed to grow in a medium containing N15. In a medium containing N15. And it was allowed to grow in N14 medium. Allowed to grow in N14 medium for 3 generations. So how many number of DNA molecules will be with N15? Will be with N15. So you compulsory confuse really. So with N15 andre illi options nimge either 4 or 2 sir anta barutte. So which option is correct? First option or fourth option? Will be with N15. So just they are asking N15 DNA molecules. So N15 DNA molecules are 2. Why? Because you can take any generation. After first generation, you can take any generation, either second generation or third generation or fourth generation. So that hybrid DNA molecules are constant. So that hybrid DNA molecules only consist of N15, remaining strands are N14 only. N14 only. So check it once. So completely N15 DNA molecule it is. So allowed to grow in N15 medium for 3 generations, right? Sorry, N14 for 3 generations. So check it once. N15 strand. So it is also N15. And new strand is N14. So here new strand is N14. Am I right? So next. So here it is N15, N14. N15, N14. So N15 and 14. So N15 and 14. But newly synthesized strands of N14 strand, N14 strand. So here also N14 strand. So N14 strand. Right? So how many DNA molecules with N15 strand in second generation? 2 only. In second generation, 2. In first generation also, 2 DNA molecules have N15. Second generation, 2 only. So you can take third generation also. See, in third generation, number of DNA molecules, 1, 2, 3, 4. So how many DNA molecules will form in third generation? 8 DNA molecules. Number of strands, 16 strands. In third generation, 16 strands. So in that 16 strands, only 2 strands are N15. Right? Only 2 DNA molecules. 2 DNA molecules have N15 strands. They're asking DNA molecules, not strands. So how many DNA molecules have N15? Only 2 DNA molecules in 8 DNA molecules. Better to take molecules only. 8 molecules, DNA molecules. So in that 8 DNA molecules, 2 DNA molecules having N15. So remaining 6 DNA molecules having N14. N14. But the 2 DNA molecules having N15 strand and N14 strand also. Yes, N15 and N14 strand. But they are asking just how many number of DNA molecules will be with N15. With N15. So that N15 containing DNA molecules are 2 only. 2 DNA molecules. So this is the correct answer. Not both strands. Any one of the DNA strand has N15. So 2 DNA molecules will be with N15. So note it down. Then you can take one more problem. See, if 50 heavy DNA are replicated 2 times in N14 medium. If 50 heavy DNA, if 50 heavy DNA molecules, if 50 heavy DNA molecules are replicated 2 times in N14 medium, if 50 heavy DNA molecules, it means N15 DNA molecules are replicated 2 times in N14 medium, are replicated 2 times, replicated 2 times in N14 medium, in N14 medium, N14 medium, right? This is the statement. So what is obtained? What is obtained? So first statement here. So first statement, otherwise first option. So 100 half heavy and half light, 100 half heavy and half light and 100 light DNA, 100 light DNA molecules, first option it is. Second option 100 heavy and 100 light, 100 heavy, 100 heavy and 100 lights. Then third option, 50 heavy and 150 light. Third option, 50 heavy and 150 light. And fourth option, none of the above. So fourth option, none of this. So none of this one. Read that question carefully. If 50 heavy DNA molecules, it means the DNA molecules having N15 isotope, right, are replicated two times in N14 medium, what is obtained? So 100 half heavy and 100 half lights and 100 light DNA molecules, first option. In second option, 100 heavy and 100 light, 100 light. Then third option, 50 heavy and 150 light DNA molecules. And fourth option, none of this. Better to take heavy DNA molecule first. N15 and N15. So it is replicated two times in N14 medium. Am I right? So it is replicated two times in N14 medium. Okay, better to take N15 strand and N15 strand it is. So this is N14 medium. So in N14 medium replicated. So newly synthesized strand is N14. Here also newly synthesized strand is N14 only. N14. Am I right? First replication. In second replication again, so N15 strand and N14 strand. Here N15 strand, N14 strand, right? So N15, N14. So here N15, then N14. Am I right? So newly synthesized strands of N14, N14. So N14, then here also N14. Okay, imagine it is two replications. So imagine one DNA molecule is equal to 50 DNA molecules. Directly they are given 50 heavy DNA. 50 heavy DNA. So 50 DNA molecules here. 50 heavy DNA molecules. So allowed to replicate two times. Allowed to replicate two times in N14 medium. So in N14 medium means here 50 DNA molecules replicated and forms 100 DNA molecules. 100 DNA molecules in first generation. In first generation. In second generation again, that 100 DNA molecules replicated and forms 200 DNA molecules. 200 DNA molecules. So totally number of DNA molecules 200. So in that 200 DNA molecules, imagine if here this DNA molecule has 50 heavy DNA molecules. Here 100 DNA molecules. Here 200 DNA molecules. So in that 200 DNA molecules, 200 DNA molecules, which option is suitable for that? Totally 200 DNA molecules. Here in second option, 100 heavy and 100 light. It is not possible. 100 heavy DNA molecules and 100 light DNA molecules. It is not possible. And 50 heavy DNA molecules and 150 light DNA molecules also not possible. Then first option you can take. In first option, 100 heavy, 100 half heavy and 100 half light. 100 half heavy and 100 half light. It means 100 hybrid DNA molecules and 100 light DNA molecules. So in option within the brackets, 100 half heavy and half light means 100 hybrid DNA. Say after second generation, 1:1 ratio, no. One is hybrid DNA molecule ratio and another one is light DNA ratio. Light DNA ratio. After second generation, that hybrid DNA molecules and light DNA molecule ratio is 1:1. But totally a number of DNA molecules here 200. In 200 DNA molecules, so 100 hybrid DNA molecules, 100 light DNA molecules. 100 hybrid DNA, 100 light DNA. So 100 hybrid DNA molecules means 100 half heavy and 100 half light. So what is the meaning of this statement? 100 hybrid DNA and 100 light DNA molecules. So which option is correct here? So first option is correct. So after second generation, when 50 heavy DNA molecules are replicated in N14 medium for 2 generations or 2 divisions, resulting in the formation of 200 DNA molecules. In the 200 DNA molecules, 100 are hybrid, 100 are light. So in 100 hybrid DNA molecules, 100 half DNA, half are heavy, 100 half are light, but remaining 100 light DNA molecules. So which option is correct? First option. So note it down. First statement. Note down that statement. The next problem. So now down one more problem. If E. coli was allowed to grow for 80 minutes in N15 medium, if condition, if E. coli was allowed to grow for, if E. coli was allowed to grow for 80 minutes in, allowed to grow for 80 minutes in N15 medium, so then what would be the percentage of, what would be the percentage of hybrid density DNA molecules? Hybrid density DNA molecules. So question is, if E. coli was allowed to grow for 80 minutes in N15 medium, 80 minutes in N15 medium, then what would be the percentage of hybrid density DNA molecules? Try to solve this. Options. First option 25%, 25%. Second option 50%. Third option 100%. And fourth option 12.5%. 12.5%. So these are the options. but they won't mention two types of mediums here. Normal DNA. So if E. coli genetic material or normal genetic material was allowed to grow for 80 minutes in N15 medium, it means normal genetic material. Okay, better to calculate at least for 2 generations. Remaining generations easily will calculate, right? So normal genetic material it is. Normal E. coli cell genetic material. So that normal E. coli cell genetic material allowed to replicate up to 80 minutes. Okay, better to take 20 minutes. It means first generation, 20 minutes. Okay, the two DNA strands separated from each other and act as parental strands, but newly synthesized strands are N15 strand and N15 strand. But what about remaining two strands? Two strands are normal strands. So not labeled, not radioactive, labeled strands these are. Otherwise not heavy DNA or light DNA strands these are. Normal DNA strands. Then again allowed to replicate for one more generation. So one more generation means 40 minutes. 40 minutes in second generation. Approximate time for replication of bacteria 20 minutes. Okay, here also same thing, that strands separated from each other and act as parental strands. See here, this is normal DNA strand and it is N15 strand. Am I right? So this is normal and here it is N15 strand. But what about newly synthesized strands? N15. Then here also N15. Here also N15. Then finally N15. It means how many hybrid DNA molecules here? 1 and 2. Hybrid DNA molecules are 2. That hybrid DNA molecules number constant in every generation. So second generation hybrid DNA molecule number 2. Remaining 2 are heavy. Then what about third generation? Third generation means in third generation they become double. They become double means 1, 2, 3, 4. 4 becomes 8. 8 DNA molecules. In third generation, 8 DNA molecules. In 8 DNA molecules, so hybrid DNA molecules and heavy DNA molecules. Better to take hybrid DNA molecules. Hybrid DNA molecules are 2 and heavy DNA molecules are 6 in third generation. Okay, better to take fourth generation again. What about fourth generation? They become double. 8 DNA molecules into 16. 16 DNA molecules. So in 16 DNA molecules, hybrid DNA molecules are 2. Hybrid DNA molecules are 2. Then heavy DNA molecules are 14. 14 DNA molecules. So now calculate the percentage of hybrid DNA molecules. So totally 16 DNA molecules as 100%. 16 DNA molecules as 100% one. Correct? 100% naga half 150% varutte, right? And under 8 DNA molecules 50%. 8 naga half 4. 4 andre. So 16 DNA molecules is equal to 100%. 8 DNA molecules 50%. 8 naga half 4. 425%. 25%. 825. Then adraga wait 850%. 8 naga 400 25%. 4 naga 200 12.5% varutte, right? Andre 2 molecules percentage is 12.5% and remaining 14 DNA molecules percentage is 75%. Sorry, so 75 12.5 ಹೋದ್ರೆ remaining percentage ಎಲ್ಲ 85 86, 87.5. Remaining 87.5 heavy DNA. Only 12.5% is hybrid DNA. So hybrid DNA percentage here is 12.5%. Directly mark ನೀವು. So 16 DNA molecules as 100%. Other half 8 DNA molecules. 8 DNA molecules percentage is 50%. Right? 8 naga 4 again 25%. 4 naga 2 12.5%. So 2 molecules percentage is 12.5. So remaining 87.5% is heavy DNA molecule ratio. So answer is fourth option for this. Note it down, no?
Students, today no chemistry class.
Okay, ma. Otherwise, you can take 2 by 16. Total DNA molecules here, 16 DNA molecules. Okay, 2 are hybrid DNA molecule. 2 by 16 into 100. Better to take like this. Directly, you will get answer. So total DNA molecules 16, hybrid DNA molecules 2. That means 2 by 16 into 100. So easily you get answer. Better to take like this. Okay. So remaining information related to this we'll see in next class.
Next class is cancelled.